This is a video regarding serial communication between 8051 and peripheral by using Keil software and Proteus software. First of all, open your Keil Mu Vision and select in Project tab New Project and give your project name as you want to write here, like save as serial communication. As you are going to write this program in C language, as serial and click on save. And a window cam for selecting devices from various manufacturer. Select Atmel from device and go to 8089C51 and click on OK. Copy standard 80 startup code, select no. And now you want to set up file, click yes, otherwise no. Open editor window, select file tab and new before writing program. Try to save it as you go from program name with .c extension. So save it and save as serial program .c. And now write the program in embedded C. Include file hash include reg.h void main shift insert. These are the header file and this is the SCON register. You can read this SCON register from the theory, the functioning of SCON register. SCON register is basically a serial control register which is of 8 bit, and 8 bit contain SM0, SM1. These are the select mode bits, SM2 and read enable pin. So the function of SM2 is enable only in 8052 controller, so it is don't care in this 8051 controller. If SM0 and SM1 pin are 00, then mode 0 is selected. It works like the shift register, and when 01 is selected, mode 1 is selected. It is a 8-bit UART variable, 8-bit UART work at a variable baud rate. And when 10 is selected, mode 2 is selected. It is a 9-bit data UART. And when 11 selected, mode 3 is working, 9-bit UART. For example, if you want to transmit a 65, so in binary we can write it as 41. So we have to transmit 01000001. So in the shift register, if you want to shift, we have to transmit from microcontroller to peripheral, and the data is this. So we have to choose shift register mode. And the next is the REM. REM is the read enable. The receive enable bit is one which show allow external data, which allow external devices connected to microcontroller. And the REM is a which by default it's a logic 0, and when it become 1 it can transmit data to peripheral devices. And the next bit is the TB8 and RB8. These are the again 8 bit, and these are also, we can say that these are the two stop bit monitors. Okay, if any problem in stop bit in transmission, TB is set to 1, and in case of reception, any problem in stop bit, RB8 set to 1. So TB8 and RB8 are the stop bit monitor, and they work only if any problem in the stop bit. Stop bit is here. For example, in this case, the stop bit is 1 and start bit is 0. And the next pin are the TI and RI. These are the transmit interrupt and receive interrupt, which is default 0. When this is when RI is set to 1, one bit data is received from external devices to mother microcontroller. Otherwise, it is 0. And in the case when TI is set to 0, TI is set is by default 0, and when one bit of data is received from external microcontroller, otherwise it is this is set to 1 when one bit of data is received from external devices by microcontroller, otherwise it is 0. These are the steps. This is following step is necessary to follow peripheral serial communication. These are the steps by which we can program the ASCON register for serial communication. So this is the process where we have to select ASCON register value. Okay, so as I told you that the SM2 is 0 in case of 8051, so it is 0 here. And for selection of mode 2, we have to write 10. Okay, so it is selected 01 here, it is selected as 01 here, SM0 and SM1. Set the bond rate, that is TH1 equals to -x. I will show you how we can set the bond rate, and it is depend on the crystal oscillator frequency. And they start the timer, so it is -TR1, that is to initialize the timer we have to set it as a 1. And the value and the load the value of with SBUF, we have to load the value until TI is set to 1, and the clear TI in RI, and we have to repeat the process from R5 and stop the timer. These are the algorithm which we have to follow for programming the ASCON register. And then last is the stop the timer. So what is this X? We have to find out this value X first, because it is required to write in our program. So the crystal oscillator frequency of microcontroller is 11.0592 by default. It is the crystal oscillator frequency which is connected. Crystal is connected to 18 and 19 pin of microcontroller, and divide this to 12. Okay, so we will get 0.9216 megahertz. And again we have to divide this by the UART, that is a 32 bit. So my 0.9216 megahertz is divided by 32, we will get 0.0288 megahertz. Okay, this is in megahertz. And then we have to divide this by X, and we know that the bond rate is 9600 kbps, so we have to convert this megahertz into kbps. It will become 28800. So we have to find this value X, then we will get 3. So now the timer timer is set to -3. So we have to put bond rate here -3. Set the bond rate, we have to put here -3. So finally I have shown you the program here. So either here we can select ASCON register, we can set here ASCON register to 50. We set the ASCON register to 50 by using 01, 01, and all the bits are 0. So if we read these values, it will become 50H. Okay. Then we have to mode. We have to select the mode. That is the we have already selected. T mode is 20H. Timer mode is 20H. This is came from timer 1 setting. Then TH1 high, timer high 1 is -3, as I have shown you already. And then we have to set timer, start the timer. We have to set the value to 1. Then we have to transmit a data. We have to transmit data by character you want to transmit. And it will become 1 after completion. Okay. And this is set to -3 because this is the bond rate at what rate? Bond rate of 9600. And next is the TI is set to 0. Okay, so now we have to make the hex code, and we want to see the output. For the see the hex code, go through source group, save the program, go to source group, add files. We have already saved this file, serial communication. We can see the serial communication.c file here. Okay. Now translate current files. We can see here 0 error, 0 warning. Now we have to select here the oscillator on chip crystal oscillator frequency, that is 11.0592 megahertz, and the target is 89C51. So we want hex file, and the output must be in serial communication folder and in Keil program. Okay, we are going to save our program here only. Okay, then we go for build target, 0 error, 0 warning, rebuild all target. And now we will see we will go to see the serial communication. Here what happened, we will go to see continuously output here. Now here we will go to see the serial communication. Okay, so if you want to see the output of this program, go to view, see the serial window. Now here we will go to see the serial communication. Okay, so if you want to see the output of this program, go to view, see the serial window. So now we will see the character I is transmitted on serial window. For this we have to first debug the program. After debugging we have to go view, serial window, UART, then go to the run. We can see that here I is continuously transmitting to peripheral devices by microcontroller. Okay, if we want to see same response on hardware tool like simulation tool Proteus, we have to start Proteus, stop the program here and wait for Proteus to open. Start new project. Save project name, communication. Next, do not create a schematic. Next, do not create. Next. So now a new project window is open. Okay, this is here. I will show you how we can take this component here. First go to the parts, type AT89C51 here, AT89C51 here. Okay, put here, then go to the instrument console, take one virtual terminal here and connect the RxD pin with the TXD of TXD, connect TXD with RxD. Okay, double click on this button, go to the program file. On program file, go to the serial communication where you so this serial communication has text file. Okay, you have to select the same frequency which you have taken during making X value 11.0592 megahertz. Okay, and run the program.